Hello and welcome to Astronomy Daily, the podcast that brings you the latest news from across the cosmos. I'm your host, Avery.
And I'm Anna. It's great to be with you.
Today we'll be looking at the slow but steady progress in UAP research and a new discovery that suggests our universe might be surprisingly lopsided.
We'll also journey to Mars to see the largest fresh impact crater ever confirmed, witness a rare cosmic dance of 3 supermassive black holes, and explore the innovative ways scientists are trying to protect future astronauts from cosmic rays.
So let's get started. Our first story brings us back to Earth's atmosphere. After years of headlines, whistleblower testimonies, and even congressional hearings, unidentified anomalous phenomena, or UAPs, are still being reported in America's skies. But getting to the bottom of it all has been slow going in 2025.
Right. And experts agree that the only way forward is with disciplined scientific study. The holdup, according to Michael Sifoni of the Society for UAP Studies, isn't a lack of interest, but a reluctance to invest serious time and money into what many still see as a wild goose chase.
Exactly. The good news is that the focus is finally shifting away from old flying saucer cold cases and towards observational and experimental science. But that requires real funding and institutional support.
And we're starting to see that happen. Institutions like the University of Wurtzburg in Germany and the Galileo Project at Harvard are developing sophisticated sensor arrays to collect high-quality, real-time data on UAPs.
But it's a massive undertaking. Robert Powell of the Scientific Coalition for UAP Studies says that if you want to seriously test the hypothesis that some UAP are extraterrestrial, you need high-precision scientific gear that could cost hundreds of millions of dollars.
And this isn't just an academic question. Former Navy pilot Ryan Graves, who now chairs an aerospace committee on UAPs, emphasizes the national security implications. He states that these objects are operating in sovereign airspace and could be collecting intelligence.
That's the angle that seems to be getting the most traction. There's even a bipartisan bill, the Safe Airspace for Americans Act, designed to support civilian UAP reporting.
Between that and the Department of Defense's own all-domain anomaly resolution office, it feels like momentum is building. Graves says he's optimistic that we may finally get some closure on this topic.
It will be fascinating to see what they find.
From the skies above Earth to the very fabric of the cosmos, our next story challenges one of the most fundamental assumptions in cosmology. A new study in the Reviews of Modern Physics suggests the universe may not be as symmetrical as we've always thought.
Not symmetrical? What does that mean exactly? I thought the cosmological principle was that the universe looks the same in all directions from any vantage point.
That principle is called isotropy, and this new evidence directly challenges it. The phenomenon is known as the cosmic dipole anomaly, and it was discovered through precise measurements of the cosmic microwave background, or CMB.
Right, the CMB is the afterglow of the Big Bang, the oldest light in the universe.
Exactly. And while it's incredibly uniform, it does have tiny temperature variations. What's strange is that these variations seem to be biased. The CMB is slightly hotter in one direction and slightly cooler in the opposite direction. It suggests our entire galaxy might be moving through space in a preferred direction at a very high speed.
Which shouldn't be happening if the universe expanded uniformly. So this throws a wrench in the standard model of cosmology.
It certainly could. If this anomaly is confirmed to be a real, large-scale feature of the universe, it would have profound implications. It could change our understanding of cosmic inflation, dark energy, and dark matter. It might point to entirely new physics, an undiscovered cosmic force, or even require us to revise our theory of the Big Bang itself.
Wow, that is a truly cosmic mystery.
And as you know, we love a good mystery here on Astronomy Daily.
From that grand scale, let's zoom in on our planetary neighbor, Mars. NASA's Mars Reconnaissance Orbiter has discovered the largest fresh impact crater ever confirmed on the red planet.
That's fantastic. How big is it, and how did they spot it?
The crater is about 50 meters wide, roughly half the length of a football field. And the way they found it is quite clever. Bruce Cantor of Malin Space Science Systems was using the Mars Color Imager, a camera primarily used for weather monitoring, when he noticed an unusual dark spot that appeared between March 27th and 28th, 2012.
So he found it by noticing something had changed in the daily weather maps.
Precisely. The crater itself is relatively shallow, and scientists believe it was caused by an asteroid only about 10 to 18 feet long. When they pointed the high-resolution, high-rise camera at the spot, they not only confirmed the crater, but also saw smaller nearby craters, and even landslides caused by the impact's shockwave.
And studying a fresh crater like this must be incredibly valuable.
Absolutely. It provides crucial data on current impact rates on Mars and gives us a pristine look at the subsurface materials that were blasted out, a powerful reminder that the solar system is still a very active place.
Speaking of active places, our next story involves a truly rare and dynamic system. Astronomers have confirmed the first known triple system where all three merging galaxies host actively feeding, radio-bright, supermassive black holes.
A triple black hole system? That sounds like something out of science fiction. How far away is it?
This system, known as J1218 plus 1035, is about 1.2 billion light-years from Earth. Using high-resolution observations from radio telescopes like the Very Large Array, scientists confirmed that all three galaxies have active galactic nuclei, or AGN, which are powered by these growing black holes.
And you said this is a first. What makes it so unique?
While a few other triple AGN systems have been found, this is the first confirmed triple radio AGN, meaning all three black holes are blasting out powerful jets of radiation detectable in radio wavelengths.
That makes sense. And I imagine this tells us a lot about how galaxies evolve.
Exactly. Finding these systems is a key prediction of the hierarchical model of galaxy evolution, where large galaxies grow by merging with smaller ones. This discovery provides a perfect natural laboratory for testing how these galactic encounters drive gas into the galactic centers and ignite the black holes, causing them to grow.
Finally today, let's turn our attention to the human element of space exploration. One of the single biggest obstacles for future long-duration missions to the Moon and Mars is the constant threat of cosmic rays.
Right. These aren't like the rays from our sun. Cosmic rays are high-energy particles from distant exploding stars, and they are incredibly damaging to biological tissue. They can shred DNA, damage proteins, and significantly increase the risk for things like cancer.
Here on Earth, our magnetic field and thick atmosphere protect us. But in deep space, astronauts are completely exposed. And physical shielding, like lining a spacecraft with polyethylene, can only do so much. The most energetic rays can punch right through.
And they can even create a shower of secondary radiation inside the ship when they hit the shielding material, which can sometimes be worse.
So, with shielding limitations, scientists are turning to biology for creative new solutions. What are they looking into?
Several strategies are being explored. One is the use of powerful antioxidant drugs, which have been shown to reduce cognitive damage in mice exposed to simulated cosmic radiation. Another fascinating area is learning from radio-resistant organisms.
Like tardigrades, the little water bears that can survive almost anything.
Exactly. By studying how tardigrades and even hibernating animals protect their cellular components from damage, we might be able to develop treatments that do the same for astronauts. A third approach is to activate the body's own cellular stress responses through specific diets or drugs, essentially preparing the cells for the harsh environment of space.
So the answer probably isn't just one thing.
That's the consensus. It will likely require a combination of improved physical shielding and a cocktail of these biological strategies to make long-duration space travel truly safe for humans.
And that's all the time we have for today on Astronomy Daily. From the ongoing search for answers about UAPs to the fundamental nature of our universe, and from new craters on Mars to protecting the next generation of explorers.
It's been an episode that shows us once again how much there is still to discover out there.
Absolutely. A huge thanks to all of you for tuning in. Be sure to join us next time for more news from across the cosmos.
Until then, keep looking up.
Astronomy.